Hello there, ladies and gentlemen. Mr. Pouts here with an answer key video we're doing for the Chapter 2 practice test. Feel free to use this as you may. Uh, Use it to check your work, to maybe help you with one that you struggled with, and to use it as a study tool. So I'm just going to go through each problem one by one, and we'll see how much we can get through. Well, I'm going to get through all of it, but we'll see how long it takes me to get through all of it. So we'll just start with part one. Section 1 says to solving one-step equation, solve each equation and check your answer. So if you look at number 1, there's some division there. And to undo division, the inverse operation that you've learned for division would be multiplication. So I'm going to multiply both sides by 7. To undo that dividing by 7. Now since that's 7 over 1, that will cancel out with the other 7 underneath to leave x by itself. And then 3 times 7 is 21. So you get 21 for your answer. You can check that, like it says to check, by plugging in 21 for x. So 21 over 7 equals 3. And that would mean that 3 equals 3, which is a good thing. So you did it correct. Now the number 2 says 12 plus r equals 3. Now you're adding the two together, and the main thing here is that the 12 is a positive. So to get rid of that positive 12 from the side of the r, since it's added to it, we will subtract 12 from both sides. Oops, 12. So again, this is the breaker for what the two sides are. Subtract 12, you get the r by itself. 3 minus 12 is going to be negative 9. Oh, isn't that something? Not sure how that happened. So let's undo that. Oh, but you do have r. What is going on here? Alright, hopefully this will start working now. But r 3 minus 12, you'd end up getting negative 9. So r equals negative 9. And to check that, you can plug it back in. 12 equals, 12 plus negative 9 equals 3. 12 plus negative 9 is 3. So those are the same on both sides, and we did it correct. All right. We are going to go on to number 3. Two-step equations. Solve each equation, check your answer. This one we've got negative 3x plus 4 equals negative 14. Now remember, to do two-step equations, you usually do kind of like PEM does backwards. You do your addition or subtraction first. So get rid of this adding this 12 or this 4 here. Because this is not attached to the variable, we want to get rid of that first. So we do that by subtracting 4 from both sides. Now, since we don't have a lot of room here, I'm going to bring this over here. But when we subtract 4, that's gone, so you just have the negative 3x on the left side. And negative 14 minus 4 is actually going to go farther into the negatives, so you'd have negative 18. So negative 3x equals negative 18. And one step would be to the inverse of division, divide both sides by negative 3. And x equals positive 6. Again, you should check your answer. You should plug that back in. And this is, I'll just divide this up. But to check your answer here, same thing, plug it in. Plug it in, plug it in. So negative 3 times positive 6 plus 4 equals negative 14. Negative 3 times 6 is going to be negative 18 plus 4. And that is equal to negative 14. So we are happy. All right, number 4. Going on to number 4. We have a word problem. It says a large cheese pizza costs $7.50. Remember, we're going to circle any numbers that we have, any key numbers. I'm going to use a different color now, so we're going to go with purple. Circle any key number. So you got 750 as a key number. Each additional topping for the pizza costs $1.25. So each topping, depending on how many toppings, you just multiply that by the 135. If the total bill for the pizza Sally ordered was $12.90, how many toppings did she order? So write an equation for the situation, then solve. Cube, circle key numbers. Underline the question. Write an equation for the situation, then solve. B, box any key action math words. So large pizza costs $7.50. Each additional cost, so additional might be one. Additional adding a topping costs $1.25. So each topping. If the total bill was $12.90, so total usually is equals, so we should have equals $12.90. And if you look at this equation, a pizza costs you $7.50 plus $1.35 per topping. So we'll say our toppings would be our x. And there's our equation. But you do have to solve. So we want to figure out how many toppings it was. So to solve for x, we first get rid of this number that's added to it by subtracting 750 from both sides. Minus 750. Whoops, we'll leave that there. Cancels out here. You have $1.35. X equals, I'm going to try to do that in my head. This is supposed to be 750. 540. And then when we divide both sides by that 135 to solve for x, you do actually end up getting 4. So x equals 4. But what does that mean? That means she had 4 toppings on her pizza. Not bad. I hope it was all meat toppings because meat lovers pizza is the best. Alright, anyway, section 3. Going on. Solve each equation. This one I'm not going to actually check, but I'm going to solve it. Remember, if there's any parentheses, we got to get rid of those first. We'd like to subtract the 7 from both sides, but since that's inside of the parentheses, we can't do that right away. So what we're going to do is distribute. We're going to distribute the 1/2 to the t and to the 7. So you have 1/2. You can change it to 0.5 if you prefer. That is up to you, but I'm going to leave it as 1/2 t plus 1/2 times 7. I think it's 3.5. Oops. Equals 32. Alright, subtract 3.5 from both sides. You still have the 1/2 t left on the left side. Equals, what is that, 28.50. 28.5. Alright, now how do you get rid of the 1/2 that's in front of the t? Well, divide both sides by 1/2. And if you remember, dividing by fractions, that's the same thing as multiplying by its reciprocal. So I'm just going to do that right away. Multiply by the 2 over 1. And over here, we're going to multiply by the 2 over 1. So t is whatever 2 times 2850 is, and I believe it's 57. So there's your t. All right, number 6. 12 is added to the product. Ooh, he's got a word problem. All right, let's circle some numbers. 12 is added to the product of a number and 5. The result is -3. Write an equation and solve. You might also say that a number is going to be a variable, but that's what we're going to be solving for. Underline the question. Well, we've got that at the end here. And then circle any numbers. And this is all before we make our equation. Or sorry, circle or box. I forgot. I already did the circling. Box any key action math words. So added to would be 1. The product of a number and 5. And the result. So result right away means it's going to be equal -3. So 12 added to something. So 12 plus, and plus the product of a number and 5. So we'll say our number is x. So plus 5 times x. Product is multiplication. Solve for x then. Alright, we're going to get rid of this number that's added to it first. So minus 12 from both sides. Still left with 5x. 5x equals negative 15. Divide both sides by 5. And you get x equals negative 3. So the number we're looking for is negative 3. Alright. I'm just going to make this a little bit smaller. Get this out of the way here a little bit. And I'm going to start using green. Alright, section 4. Solve each equation, check your answer. So we've got some equations with variables on both sides. We've got 4 of them here. Alright, looks like the first 2 are going to get an answer. The numbers 9 and 10 will either be identity or no solution, I think. So the first 2, remember, first of all, whenever there's subtraction, change it to adding a negative number. So over here, I'm going to do that on this one right away too. Do that here too. Alright, but we want to try and get the variable term just on one side. So for number 7, I'm going to get rid of it from the right side because that's the smaller one. So I'm going to subtract 3y from there to cancel out the 3y. And on the other side of my equation, I'm also going to subtract 3y. That leaves me with 4y plus 5 on the left side equals negative 31. That's why I put that negative over there. So 4y plus 5 equals negative 31. Alright, the thing that's not attached to the variable we'll get rid of first by subtracting 5, doing that inverse operation. So 4y equals negative 31 minus 5 becomes a bigger negative, so negative 36. We divide both sides by 4. Y is all by itself, and it's equal to 36 divided by 4 is 9, so it's a negative 9. Alright, number 8. Let's do some distributing again here. 1/5 distributed to both of these parts. Some of you prefer to change it to 0.2. 1/5 is 0.2. That's totally fine if you want to do that. Not crucial, but might help. So if you want to do that, that would be 0.2x. And then 0.2 plus negative 1.6 equals x plus negative 16. Alright, well, let's get the variables on one side. So I'm going to get rid of the smaller one. So minus 0.2x from both sides. There are two sides. Minus 0.2x. You're left with negative 1.6 equals 0. This equals 0.8x plus a negative 16. Alright, let's get rid of the negative 16 by adding 16 to both sides. You're left with, this is going to be 14.4. Feel free to check that on your calculator. But that's equal to 0.8x. And then lastly, divide both sides by 0.8. And you're left with x equals, let me check that. 14.4 divided by 0.8. 18. What a nice answer. Lovely when it works out like that, huh? All right. Let's go on to these 2 longer ones, numbers 9 and 10. And what I think I might do with these is take these and put them on their own slide so I have enough room for them. Oh, looks like I got a little of that green in there. That's okay. So it says solve each equation. It's either going to be identity or no solution. So we'll see what we end up getting. Going to be a lot of distributing here again. For both of these, they're both multi-step equations with variables on both sides. So this one right here, distribute the 2.6 to both of those and distribute the 2 to both of these in here. These are still our two sides. So it's going to be 2.6x plus, that's 5.2, equals 2.6x over here plus 4 plus 1.2. So any like terms we can combine right away. So that's going to be 4.2 and or 4 and 1.2. Otherwise, there's no like terms because on the left side it's just an x term and a non-x term. So we have 2.6x still over here plus 5.2 equals 2.6x plus 4 plus 1.2 is 5.2. All right. Get the x's, get rid of the x's from one side. So I'm going to take away with this one minus 2.6x. Do it over here. Ooh, it cancels out over there too. You're just left with 5.2 equals 5.2. Whew. What does that mean? Well, that means that is an identity. When they are equal on both sides and the variables are gone, that's an identity. Meaning there are infinite solutions. You can plug in anything for x as long as it's the same on both sides and it'll work. So let's see if number 10 is an identity or a no solution situation as well. Looks like we've got distributing twice on the same side of the equation. Changes to plus and negative 3, so we distribute the negative 3. So we have 2x plus 4 equals 5x, 5 times 1 plus 5, plus negative 3x, plus negative 6. Negative 3 times 2 is negative 6. On the same side here, we have some like terms again. So this plus 5 and this plus negative 6x. Then we have the 5x and the negative 3x. So we still have 2x plus 4 over here. The x's, we have 5x minus 3x would be 2x. And 5 plus negative 6 is going to be plus negative 1. All right, get rid of the variable terms from one side. You have to do that to the other side. So that cancels out as well. You're left with 4 equals negative 1, which we know is not true, and that indicates that there is no solution. All right? I mean, after the distributing, it didn't end up being too many steps, and you notice that it is a no solution situation. All right, let's go back then to the last problem in this page where we have to solve for x in this literal equation. Weird equations, but that's okay. So we have a over b times x minus c equals 0. Now the a, b, and c, you can picture them as being numbers. So you're going to do the same operations as if they were numbers because we're trying to solve for x. So if there's just minus c over here, we're going to get rid of that part first because it's not directly attached to the x. So we undo that subtraction by addition. Add c to both sides. We're left with a over b times x equals 0 plus c. Well, 0 plus anything is just whatever that thing is added to it. So this is just c. All right, now a over b. How do we get rid of an a over b that's multiplied by an x? Well, we divide by a over b. But as we said before, that's the same thing as so you divide by a over b. But that is the same thing. I'm going to erase that and say that's the same thing as multiplying by its reciprocal. So really you're just multiplying by, oh shoot, got to put the marker back on here. We're going to multiply that side by the reciprocal, and the reciprocal is just a flip version of it. That'll cancel out the a's and the b's. But then you do that to the side as well, times b over a. So x equals c times b over a. You can leave it like that if you want. Or if you wanted to make this into a fraction, it'd be c over 1. And then you multiply straight across. And you could say that, or x equals c times b all over a. So that's page 1. A lot of solving equations. Page 2, we're going to get into the other things that had to do with rates, ratios, proportions, unit rates, and percents. So if you need to take a break, feel free to take a break. Pause it, come back. You can skip around. Otherwise, we're going to keep going. All right, so on page 2, section 6 is about rates, ratios, and conversions. So, well, let's take our first one, number 12, 260 seconds. We want to change it to minutes. So let's make this as a fraction, 260 seconds over 1 minute. No, not even over 1 minute. We just want to make it over 1. Sorry. 260 seconds over 1. And we're going to change that to minutes. So we're going to use the conversion with minutes on the bottom. Well, that's interesting, isn't it? So we want to have, there we go. Let's have seconds on the bottom and minutes on the top. How many minutes? So then there'd be 60 seconds on the bottom for 1 minute. All right, so essentially what we're doing is we're dividing it by 60. Because if you multiply across, this will cancel out. And then we're doing 260 divided by 60, which actually gets us 4 1/3 minutes. Well, what is that in minutes and seconds? What's 1/3 of a minute? Well, if we have 60 seconds in a minute, 1/3 of that would be 20. So 4 minutes, 20 seconds. If you can read that, that's 4 minutes and 20 seconds. All right, number 13, let's change 5 pounds to ounces. So 5 pounds over 1. And we want to be ounces on the top. There's 16 ounces per 1 pound. So they'll cancel out the pounds and do it 16 times 5, which is 80. 80 ounces. All right, that would be that section. Now, section 7, solving proportions. We should all know how to solve a proportion properly. The best way that'll work for every single time you do a proportion. That is cross multiplying. So if I cross multiply here, that goes across there, that goes across there. I have 48g equals 12 times 20. 12 times 20 is 240. And then divide both sides by, remember, when we do cross products, we set those two cross products equal to each other. Then we can solve the equation by dividing both sides by 48. And g equals 240 divided by 48. It's 5. Nice. So g equals 5. All right, next one. 12x and 15 times 18, so it'll be 12x. I don't remember what 15 times 18 is, but we can check on a calculator. It's 270. And when we divide both sides by 12, I don't know that we get a perfectly even answer, but 270 divided by 12. Oh, did that wrong. Divided by 12. 22 and a half. All right, looking good so far. Now we've got one more. This is probably the most challenging one. It's a multi-step one. What I'm going to do with that is I am going to do that on a separate slide like I did a different one so that we have enough space. So this is number 16. Number 16, we are still cross multiplying. So I'm going across like this and across like this. But I need to write that out. So that first one I did was 3 times 2c minus 3. Set that equal to the other one, which is 5 times 7c plus 4. Do my distributing property. Whoops. Come on. Okay. There. And there. This would be 3 times 2c would be 6c. Minus 9 equals 5 times 7 is 35c plus 20. Now remember, let's get the variables to one side first. I'm going to actually change this to a plus -9 so I don't forget that that's a -9. But I'm going to subtract 6c from here and do that from the other side. I have -9 equals 29c plus 20. Now to solve for c, I got to get rid of this extra added floating number here by subtracting 20 from both sides. So I have 29c is left over here. -9 minus 20 would be -29. And when I divide both sides by 29, a negative divided by a positive would be a negative, so it's a -1 is equal to c. A lot of work for that problem. You have to do your cross multiplying and then solve a multi-step equation with variables on both sides. Alright, that is good. Let's go back here and see what we have on this slide. Let's do some more of this. So number 17, it says the scale of a map is 1 centimeter to 50 miles. We've done scales before. We did scales on a blueprint. Determine the distance between two cities that are 4.2 centimeters apart on the map. So if I do 1 centimeter, that's my scale, is 1 centimeter to 50 miles. That's equal to, we're going to do 4.2 centimeters. And we want to figure out how many miles that would be. So when I cross multiply, I get 1x, or just x, that's nice, equals 5 times 4.2. So that would be x is equal to 23. That is, or sorry, 21. That'll actually be 21. So that means 21, don't forget the label, which would be miles. Figuring out how many miles they are in real life. Alright, jumped into section 8. Just a couple with similar figures. Again, scaling, but dealing with similar figures. So, if we would to look at this, we have two similar figures, and we have some corresponding parts. Whoops. So this corresponds with this, so we have, and then this corresponds with this. So if we do 12 over x as part of our proportion, we have to do the corresponding part. So 8's going to go on top and 10's going to go on the bottom. And when we cross multiply here, 8x equals 120. And you divide both sides by 8 to solve for x. X is equal to, well, 120 divided by 8. 15. So x equals 15 here. Alright, moving on to number 19. Still in section 8 says number 19. A tree casts... Ooh, it looks like we're going to have to make a picture. But a tree casts a shadow, a 26-foot shadow. This is our tree. It's a really bad tree, but casts a 26-foot shadow. So this is a shadow. It'll be 26 feet, because this is where we see the shadow. A boy standing nearby, so here's our little boy here, standing nearby, casts a 12-foot shadow, forming similar triangles. So they'd be similar triangles since the sun is coming from the same place. His height is 4.5. feet. We want to figure out how tall the tree is. So again, we can set up another proportion. Do x over 26 equals the corresponding part, so 4.5 over 12. And then you have a proportion to solve, and you get 12x equals whatever 4.5 times 26 is. And that's 117. And divide that by 12 to get your answer. It's not going to be a perfect answer, but 9.75. That means the tree is 9 3/4 feet tall. Okay, that seems to make sense. If the boy is 4.5 feet tall and he casts a shadow of 12 feet, the tree would be 9.5 feet tall, or 9 3/4 feet tall, and it seems like it would make sense. So that's section 8. All right, section 9. I will set up the proportions for you, and then I'll give you the answers. I'm not going to work through all the work. We're running out of space on here, and that's just how it goes. But if you can set up the proportion, we've been doing plenty of proportions, so you should be able to solve them. Don't forget, though, when we're doing percents, typically it would work saying is, oops, I bumped a button now, is over of equals percent over 100. And that's something to know. So for number 20, we don't have the percent. It says what percent. So the is would be this 36 or 7, because that's by the is. 37 over the of, which is 111, equals, we're missing the percent, over 100. And when you solve this, it will end up being 33%. Number 21, we have the percent. So, and we're missing a number that would be of, so we have the is. So 102 over of, which is x, is equal to 60 over 100. When you solve this one, I could be wrong, but I think it's 150. Let me check. Oh, 170. It is 170. That makes sense. So the number that we're looking for that we should get there is 170. All right, and then lastly, number 22. Well, we have 23 as well. 22 I'll set up in red. So we have the percent and we have the of. We're looking for what is. So x over 150 equals 72 over 100. And I don't remember this answer either, but I'll do it for you. And I cross multiply, do that, and then you divide by the 100 and you get 108. So x equals 108 for number 22. All right, and there's one more. It says 23. It says there are 21 females in the algebra class. If 75% of the class is female, so we're going to have 75 over 100. How many of the students are in the class? So think of part over whole. The part would be the females. And we're trying to figure out the whole amount of students that are in the class. So there's our proportion. When we solve it, you end up getting x is equal to 28, and that would be 28 total students. All right, on to our last section. Change expressed as a percent. This is the last section of the chapter. So we want to make sure we say if it's an increase or decrease, and we also want to find the percent. Rounded to the nearest whole percent, so a whole number, no decimals. So to find the percent change, you figure out the change on the top, which will be 9950 minus 9250 would tell us the change all over the original. When you divide that out, you end up getting 0.07 something. Now to change that to percent, you move it over 2 spots, recall? You multiply it by 100, so it will end up being 7%. And since it went down in price, that is a decrease. All right, same thing for number 25. Figure out the difference. So I'm just going to take the bigger minus the smaller. So I'll do the 22.75 minus 19.25 all over the original, which is 19.25. So you end up getting 22.75 divided by minus 19.25. That's going to be 350 divided by 19.25. So you get a 0.1818 repeated. So again, move that decimal 2 places to the right, and it's going to be 18, rounded to 18%. It goes up, so it's an increase. All right. So that's how you do section 10. The bonus, I don't think I'm going to go through it. We'll read it through, and I'm going to leave that one for you. It says, solve the following problem by working backward. During an evening out, Dean paid a cab driver $20. He then spent $25 on dinner and half of his remaining money on a painting. He bought an umbrella for $23.75 and had $42.15 left. How much did he have at the beginning of the weekend? Huh. That's a good thinker. So you can work that out how you would like to work that out. Otherwise, feel free to jump around and check the different work for the different problems. I hope you can read everything. I hope you can hear everything. And I hope this helps. Good luck on the practice test and good luck on the actual test. We'll see you later.